Alrighty, good evening, everyone. Welcome to tonight's weather chat with Timmy here. We are going to talk about some storms that are ongoing across parts of the deep south right now, courtesy of a kind of decent area of low pressure. And we're going to take a look at the weather map here in just a quick moment. But one thing I do want to show you guys here is it looks like we might actually have an observed tornado on the ground. Now, this is all the way down in Louisiana, so let's go ahead, folks, and take a little bit of a look here over at our radar imagery. So this is the latest scan here. And again, if we zoom out a little bit just to kind of give you an idea of where we are, we're not too far away from Alexandria, Louisiana. So we have your typical radar image here on the left. This is the one that does the precipitation. And on your right, you will see what is known as a velocity radar image. Now, we use the velocity radar image in weather to kind of help us see the winds within a thunderstorm. And the way that these work is that reds are winds going away from the radar, greens are winds going towards the radar site. In this case, the radar site is right there. So this, ironically, is pretty much right over the radar site over in Alexandria, Louisiana. So we do have right now, according to the latest update on the warning here, the tornado warning that's in effect there is an observed tornado on the ground. However, let's go ahead and see if we can't take a little bit of a look at it here. If we zoom in a little bit, you'll notice this little notch right here. And again, this is the latest radar imagery now updating here. And basically what we look for when it comes to tornadoes is kind of a contrast in these colors. Now, again, you can see a pretty big contrast right here. We got winds going away from the radar site here and winds going towards the radar site over here. Well, that's just kind of a little bit of a wind shift within the thunderstorm here. Again, if we kind of zoom out a little bit, we can see that this is a pretty, decent sized thunderstorm there. So it has a lot of air that's being pushed out here, kind of a little bit of a gust front, I guess, if you wanted to call it that. But if we look within that, and this is not unusual sometimes when we have these the way this thunderstorm is kind of structured, and we'll talk more about this as severe weather season comes into play here. But take a look. You can see there's a little bit of this notch right here where we see kind of this increase in the outbound winds. And if we look carefully, we can see that there's a little bit of a notch here of winds going the other direction. So when we see this type of a signature here on a radar, it's a good indication that there's probably at least some rotation. Now, in this case, an observed tornado has at least, occurred. Now, again, whether it's a big one or a little one, still a little up for debate here. As a matter of fact, let me go ahead and just make sure that we do have our storm reports on here. Let me double check, make sure that we have those flipped on, just so we can make sure we don't miss anything here. So anyways, we'll wait to see if there's any reports that come in exactly as to where that thing was, but just kind of interesting there. Doesn't look like it's a strong one. Probably what we call in meteorology a little bit of a spin-up tornado, which are ones that kind of happen very quickly. Now, again, this is not the only active tornado warning that's going on in parts of the Deep South. As a matter of fact, if we were to go all the way over towards the Natchez, Mississippi area, and if you've never been there before, it's right up on the river there. It's very interesting city, kind of an old city, at least by United States standards. And what we've been taking a look at here with this thunderstorm is you could see a little bit here of what appears to be kind of more or less somewhat of a hook here. And without going into too much details here of the overall structure of the storm, but what we see here on the, this typical radar imagery that you're used to seeing, the rainfall one here, is we have kind of the storm itself here, and then it looks like there's this little bit of a notch that extends outwards here. So what we're probably seeing is the inflow of the thunderstorm is right about here, and of course we got some, the rear flank downdraft kind of coming down on this section right about here. So taking a look here at the velocity imagery, you can see that these colors are a little bit more pronounced than what we saw with the storm over in Alexandria, Louisiana. But here's the thing to keep in mind, though, is that in weather, we kind of consider this, at least the way it looks this immediate moment here, is that this is kind of somewhat of a broad rotation. Now, I say broad rotation. Let's put it for you this way. Now, with these supercell thunderstorms, they have rotation within them. It's called a mesocyclone. And honestly, a lot of times with, when we're dealing with very strong thunderstorms, sometimes you will see this there, and there might not actually be anything on the ground. And again, it's the rotation happening within the thunderstorm. And with these stronger type of supercells, especially the ones that produce long track tornadoes, that mesocyclone is very evident, and it's, very vivid on the radar imagery, especially the one there on the right. which is where we can see it here. But when I say broad rotation, what do we mean by broad rotation? Well, tornadoes are very small, okay? Well, relatively speaking, they're not big. When we're talking about broad rotation, we're talking about rotation that's occurring higher up in the thunderstorm, but it's not very condensed, if that makes any sense here. Again, we don't expect to see a 10-mile wide tornado. That would be that would actually be pretty cool. But that's not what's happening there right now. So we do see this thunderstorm is rotating. But again, because we're not necessarily seeing these values necessarily too strong per se, or very close up right against each other, probably not anything at least immediately on the ground at this time. But naturally, that could easily change. Again, we saw the latest radar update here, and it looks like that storm is actually kind of tracking a little bit towards the north. And I will say this is kind of very defined here. I wouldn't necessarily, there's a little bit of kind of a hook echo signature here. A little bit tricky to see it within, kind of this heavy precipitation that's going on all around it. And if you've ever been down to the deep south, when it rains down there, it rains. It's a heavy rain. It's very humid down there. And so a lot of times when we look at these supercells, sometimes with these severe weather events down in the deep south, they tend to be harder to see, at least on the radar imagery, not the velocity, but the radar imagery, just because there's just so much precipitation going on there. But again, there it is right there. Again, pretty defined looking supercell there. I think that'll be something that'll be interesting to watch maybe here over the next 15 or so minutes. Let's go ahead and take a look up to Jackson, Mississippi. And it looks like there's kind of another little bit here of kind of another supercell here, and this was actually kind of interesting. And this, this, I guess I would say we probably should have started with this thunderstorm. It's a pretty good example here of when we talk about the winds of a thunderstorm pushing outwards, kind of the straight line winds here. If we take a look at the image there on your right, that's the velocity radar image. You can see this kind of this section here of the green wind. Again, those are winds going towards the radar site. So in this case, we're looking at the radar imagery out of Jackson, Mississippi here. So we got this thunderstorm that's, pushing some air outwards, and we can see those winds are kind of more or less somewhat tracking their way. So that's some straight line features. But sometimes what we see with this, and this is kind of somewhat of a signature, a little bit of a bow echo. Now, again, folks, there's a lot more going on with this. But long story short here, sometimes, especially on the northern edge, with the way that the air flows around these thunderstorms, sometimes we see this little bit of a bowing section happening. Basically, the winds are kind of racing out a little bit ahead of the thunderstorm, and it creates kind of this, backward C shape, a bow, like bow and arrow, here on the radar imagery, and that's kind of what we're looking at there. But if we were to take a look up here, you can notice that those red colors kind of uptick a little bit here. They get a bit brighter. So sometimes what we see with these bowing segments is we do actually sometimes on the northern edge can see a little bit of rotation. And as a matter of fact, if we were to kind of line it up here, it looks like this is probably somewhat here of a hook echo, albeit not very defined. But again, it does kind of line up with a little bit of that slight uptick there in rotation that we are seeing north of Florida, Mississippi there. So interesting kind of setup there. And the whole atmosphere down around this area right now is not necessarily, it's not necessarily textbook of a major tornado outbreak, but it is certainly one nonetheless that does feature, at least some favorability for a few tornadoes here and there. Let's go ahead. Whoa, we lost the radar image there really quickly. There it goes. All right. Let's go ahead here and take a look back at our big storm over here, the one that is past Fayette, Louisiana, and not Lafayette, but Fayette, Louisiana, or sorry, Mississippi. Oh, wow. I think you're getting all the states mixed up here. Basically here, it looks like, see, there's still that mesocyclone rotating within that thunderstorm, but it does not look like, at least at this moment here, that circulation, although it's defined and it is broad, it does not necessarily look like there's probably anything on the ground, at least at the moment, just given how we're not necessarily seeing those values kind of increasing more or less. It's hard to explain. Well, it's not really hard to explain, but without going into so much detail, because folks, we could talk about this all night. This stuff is pretty fun. Radar meteorology, always a very fun thing. So again, you're looking there into the thunderstorm. There you go. So a little bit of a notch there. That's pretty interesting. Let's go ahead and go back and take a quick little look over at our good friend down around Alexandria. See here how our little guy is doing, and it looks like there is still somewhat of a little bit of a signature here. Are they still calling it observed? Yes, they are. They are still calling it observed. Let's just see what they got on their text here. That a confirmed tornado was located moving east about 25 miles an hour. Uh, yeah. So it looks like they still believe that tornado is on the ground at least. And it would appear to be probably right about here. Now, here's something that's interesting that we're now kind of seeing is it looks like the rotation may be trying to redevelop itself a little bit farther off towards the east here. We'll see what the next velocity scan kind of suggests here, because here's the current rotation, the one that prompted that observed tag within that within that tornado warning. There may be maybe a little bit of a new one trying to develop, at least a little bit of new rotation trying to develop, maybe out ahead of that. Again, not necessarily unusual, be pretty interesting there. Let's go ahead and flip on over, actually. We'll see here if we can't take a look at something called the correlation coefficient. What is this in meteorology? Well, the correlation coefficient, now that we have dual pole radar, the radar measures, sends a beam one way and it sends another beam, one beam vertically, one beam horizontally, more or less. And basically what it's able to do is it's able to detect the size of objects. Now, let's think of a thunderstorm here for a moment, okay? We're in the middle of a thunderstorm, there's raindrops. Most of those raindrops are going to be the same size, okay? So the radar kind of measures things, and it says, hey, a lot of the things in this area are the same size, a lot of this material. And so that gives it a correlation coefficient. For those of you who've ever taken statistics, the higher the correlation coefficient, the more things are related, if that makes any sense. If you were to use, a scatter plot and draw a line along with it, do those data plots kind of fit up with the equation that you have? Again, there's your correlation coefficient. Typically, 1 is the highest, 0 is the lowest correlation coefficient, at least in normal statistics. So what the radar is doing here is it's determining, what's the correlation coefficient of all these objects here? Are they all generally kind of the same size? Well, if a tornado happens and it starts picking up debris can range anywhere from a leaf to potentially a roof of a house. So those are a lot of different sized objects that the tornado is just kind of hurling up. And so the correlation coefficient will decrease. And so when we look at the radar imagery here, what we kind of look for are holes, more or less, here in the correlation coefficients. Now, what do I mean by that? I mean that we expect that, 99.99% of these radar images, always show high correlation coefficients, but we look for an area where those correlation coefficients drop off. And do so in kind of somewhat of a circular type of fashion or whatnot. Now, with strong tornadoes like the one that happened back in Rolling Fork last March, which I was actually down there a few months later, and the damage is still there. But Rolling Fork, that tornado was so strong it lifted that debris up thousands of feet into the atmosphere, or thousands of feet up above the ground level, and the correlation coefficient was showing that signature at multiple level scans there. So again, that's a good indication of a very strong tornado. In this case, looking at this right now, it doesn't appear that there's really anything of note. If we kind of loop it here really quickly, we'll go back and see maybe there it is right there. Okay. So when we first started this chat, we were talking about an area down around Cora. Take a look. There it is right there. See that little dot that just kind of travels its way? Little tornado right there. Loop that again for you so you can kind of see it there. Now, again, obviously, this is a loop from just a few moments ago. Over the past, what is this going to be? 15 or so minutes. So again, it was right there around Cora, and then it tracked its way, and now it's still, if we take a look at it here, it looks like it's still kind of visible around Hinston. Whether or not it might still be on the ground, or that could just be some of the debris falling. up for a little bit there of debate, but it looks like they're still continuing this as an observed tornado at this time. So it could very well still be there. So that's kind of cool. If you remember back when we first started doing these weather chats, we were looking at one up around Michigan. We saw the quick drop off of the correlation coefficient. So nowadays in meteorology, or at least for the National Weather Service, that little drop off is just enough to change the text from radar indicated to observed. Even necessarily if no one sees it, because now we have a pretty good idea, and it's been this way for quite a few years now. When you see that, that's probably Trento on the ground, or there's somebody in a plane just throwing random objects out in such a fashion that the radar detects it. Be pretty impressive, but there you go. So we're still looking at this little guy here, and as we mentioned, it looks like that the Trento that was on the ground has since weakened off. But let's go ahead here and see, because I mentioned a few moments ago that we could maybe see a new area of rotation trying to develop. And it looks like it's still kind of there, but again, the storm, at least a little bit here, looks like it's kind of lost some of its structure here. But again, it could just be because it's so close to the radar site. So we'll keep an eye on that guy. Let's go ahead and go back to our good friend up here in Fayette, Mississippi. We were taking a look at that big behemoth of a thunderstorm there. Let's go ahead and see if we can't get that Jackson radar back up. There it is. Let's go ahead and check out our Jackson radar and take a look at that. They have this as still radar indicated. But look at that. That's really starting to become better organized here. And I'll tell you what, looking at this right now, this is a pretty interesting signature here. Let's go ahead and see if I can't kind of mark it up here for you a little bit. So if we're kind of looking at the airflow of this here, basically we're looking at this section right here. So we got the inflow of the thunderstorm here. And then, of course, we got that rain-cooled air being pulled down because of the inflow. And again, there's a little bit of that rotation there. Now, if we flip on over here to this radar imagery and we kind of line it up a little bit, mind you, this velocity radar image is kind of lagging a few minutes behind. We're kind of looking generally at this area right here. So we're going to look for kind of a tightening up a little bit here of this rotation, which would be a good indication that something's on the ground. But according to at least the overall, radar signature here, we are kind of looking at kind of a decent little structured supercell there, a little bit of a thunderstorm here. And again, we mentioned the term hook echo. It's this right here. Generally is what we're referring to is that part right there. And now it might be a little bit hard for you to see, but if we were to kind of outline this thunderstorm a little bit, again, this might not be the best thunderstorm to use for this example, but for those of you who know your supercells, if we were to kind of highlight it just a little bit there you go. So this is, this would be what we would kind of consider, to be the main part here of the supercell, the one that you kind of classically will see sometimes there. And again, it's this little notch right here, the hook echo. And again, what you're seeing here is basically that air is not only, it's not only sucking in that warm, moist air, but again, that same thing is also helping to pull down that rain-cooled air from the center part here of the supercell. So again, it just all has to do with dynamics and everything with the way that the winds work. And as I mentioned before, folks, when we get into maybe some more organized severe weather outbreaks, we'll take a lot of looks at supercells. Supercells to me are one of the most fascinating things in weather. And what's very fascinating about them too is that a lot of them follow, very similar properties. It just always fascinated me how supercells, thunderstorms, even though each one is always different, nothing in weather ever repeats truly, but they all kind of take on this very similar shape. And there's reasons for that, but it's very fascinating. And this gives you kind of an idea of some of the wind shear environment that's also happening. I mean, again, if here's the main part of the thunderstorm, the tornado's happening down here, it gives you an idea of the wind shear that's happening, the change in the wind direction and speed with height. So that's, again, a very necessary thing if you want a tornado to develop, is you need a good amount of wind shear here. So this supercell thunderstorm, again, there it is right there on the radar imagery. Again, I know there's other storms attached nearby, but this to be, with everything else lining up, is, again, probably where I would draw the boundary of that particular supercell. And again, what we're kind of watching for a little bit here is that there's going to be any, sudden upticks here. So we got a very broad mid-level rotation here, and maybe even a little bit in the lower levels, but we're waiting to see if it maybe increases. And again, with these supercells, sometimes they cycle. All right. What do you mean they cycle? Well, the rotation, the mesocyclone is still going to be there, but sometimes it kind of re-intensifies a little bit and then weakens off a little bit. And that's sometimes what helps, for a single supercell to produce, kind of a little bit of a family of tornadoes, more or less. There is some of that cycling. Or you can be like the Mayfield tornado back in 2021 that stayed on the ground for an insanely long time. I remember tracking that thing. That thing was impressive. And that was in December too. So yeah, there was a lot of things that were really funky about that particular tornado outbreak. But yeah, that Mayfield, Kentucky one, I was watching it while it was happening. I remember I was sitting there at this TV station, and I had it up on the radar, and that was my whole evening. And I still got some of the radar scans saved. So when we talk about that, But yeah, that thing was impressive. It was on the ground for a long time, and actually, when it originally happened, we thought that it might have been because there were two very long track tornadoes from that same supercell. And we initially thought that it might have been one long tornado, but when they did the surveying, and this is why surveying is very important when it comes to tornado climatology stuff, when they uh, when they did that rating, they determined that the tornado, the first one, had lifted, and then it produced a second tornado that was very brief. It was just a little F0. It was on the ground for maybe about a minute or so, and then it went back up. Then it produced the other long track one. So it looked like on the radar and everything that it was one long trail that stretched from, I believe it was northeastern Arkansas all the way into central Kentucky. But in reality, it was actually it was actually two long track tornadoes separated by a very, very quick little intermediate. It was very fascinating. I'm getting off topic. Again, we're taking a look at that supercell thunderstorm there, not too far away from Jackson. Again, it still has that structure there a little bit, watching that. And taking a look here, again, still trying to rotate a little bit. If we were to flip over to our correlation coefficients, we do not see any signature right now that would indicate that something's on the ground. This is some bad radar return right here. Same thing right there. That'd be very interesting, though, if that shape actually existed. That would be one interesting atmospheric phenomenon. But now, bad radar scan there. That's kind of a little bit of a look at what is going on with that. Alrighty, everyone, let's go ahead here and kind of take a look at the latest weather map and kind of explain to you here a little bit of what is going on in terms of the weather. Why are we seeing all of this today? Let me go ahead here, folks, and put up. Let's go ahead and put up the old surface map here and take a little bit of a look. We got this area of low pressure right now, not too far from Muskogee, Oklahoma. It is occluding right now, but overall, the whole surface area, of the low pressure is likely going to continue on. But long story short, this is the center of the low pressure there. Not necessarily the strongest low pressure in the world, but it's enough to get the job done. It's got a cold front. It's trying to push its way through. Temperatures behind it, not necessarily cooler, but there is a secondary front, which is kind of pushing those temperatures back down to the 50s. Out ahead of it, we're seeing a very warm and humid air mass, as is normally the case across Louisiana and a good portion of the Deep South. If you've ever been there in the middle of summertime, it is absolutely miserable. It is hot, it is humid, and you go outside for about 5 minutes and you feel like you're going to fall over. That's not the case today, but it is still humid out there, and it is pretty warm. Temperatures lower 80s, upper 70s as of the last surface update, and even at the last some of the surface observations I was looking at before this that were happening still showed a pretty warm air mass here. So it's good feeding the low pressure, but now the cold front has overrun it, so we'll probably see a new center of low pressure developing. Again, very warm air mass here, winds coming almost straight out of the south here. Let's go ahead and take a little bit of a look at the upper levels here associated with all this, and what you see is a very, very pronounced upper level low right over Kansas City. And if we take a look here at the upper level wind speeds, you can see how there is this nice little notch here. In fact, if we were to go up even higher into the atmosphere, you can see this wonderful little jet streak right over Arkansas, winds at least 130 knots there, according to this particular analysis. And again, this is a very good area for, low pressure enhancement here and there. Again, we talked about upper level divergence before. So again, this whole area pretty good. But again, these are some very strong winds blowing their way through, easily over about 100 knots or so in parts of Louisiana. Again, but we're looking very high up at the or very high above the surface here, almost about 30,000 feet. If we were to flip down over towards the surface here, again, we can see those winds coming out of out of the south. So there's a very good amount of wind shear there. And that's kind of the primary factor here that's helping out these thunderstorms because the let's go ahead and flip up the Cape values here if we can't. Uh, the Cape values here, this is convective available potential energy, which is a whole other thing. The mix level is, we'll get to that at a future date. I don't feel like going into that tonight. This video is already kind of getting a little bit on the long side, but again, about 1,000 joules per kilogram. So modest, but again, the main thing that's helping these thunderstorms to be, strong and even, supercellular is the amount of wind shear that is out there. So this is not an unusual setup, especially during the winter months down across the deep south, especially the Gulf Coast area. When you get these temperature contrasts like this, these strong low, they don't have to necessarily be the strongest low pressures, but a lot of times this type of setup is not unusual. And so, yes, for those of you who aren't familiar with the deep south, tornado season for them is almost all year, to be quite honest, but really is winter and going into spring when that temperature contrast is the greatest across the deep south with those low pressures and upper levels are strong enough. For places like Oklahoma and the Great Plains, it's late spring into early summer. And again, there's kind of all tornado outbreaks generally have kind of the same ingredients, but a lot of tornado outbreaks that occur in the plains often have the assistance of a dry line, which you don't normally see the dry line going much further than Arkansas in most cases. Honestly, you don't really see it getting past this the oh boy, what's that river? That's going to drive me nuts. You don't see it really getting past eastern Oklahoma very often. Sometimes it does, but generally not. But again, that dry line can sometimes help spark off those tornado outbreaks, but for a whole other reason. We'll talk about that at a future date there. So nothing necessarily unusual for the Deep South. Let's go ahead and take one more look over at our good friend. Man, that thing looks good. Wow. That is still looking pretty good. Oh man, this thunderstorm wants to drop a tornado, and just as we were talking about it earlier, let's take a look here. They also have a new tornado warning up around Madison and Canton here, and if we were to go ahead and kind of take a little bit of a look here, let's see what the past radar scans were. Yeah, it looks like they're thinking that. I think they might be expecting that something's going to pop up right here, right at that notch. You can see right there. So again, we were talking about how sometimes with these storms, but this isn't necessarily a bow echo situation anymore. And there it is. Take a look at that. It looks like we are starting to see something getting itself kind of organized here. So again, let's take a look here at our supercell thunderstorm, folks, and kind of outline this here really briefly like we did the other one. It looks to be that it's about like this. So little bit of a high precipitation one with some of this going on down here. But again, this is kind of the area to be watching. And let's take a look here. We're going to give it another couple of radar scans here for those of you who are curious to take a look here. But it does look like this might be trying to get itself organized here. So we definitely have some rotation, not the strongest rotation at the moment, but that could easily change. We are looking at the low levels here, and let's go ahead and see if we can't flip on the correlation coefficient, see if anything's going to pop up here. Nothing necessarily quite yet. We'll see here. Let's go ahead and we'll give it, we'll wait another minute here or two, and we'll see if anything kind of fires up with this little guy. And what we're probably going to do here in the next couple of minutes is we might stop this video and then kind of continue on with a second video, kind of splitting them up here just a little bit. Makes it easier for uploading purposes. So let's go ahead here, and we're just going to wait really quickly with this. And I tell you what, that's kind of a good low precipitation area right there. Like I said, we're still pretty close to the radar site there, and I'm kind of surprised here. This thing still hasn't dropped. It looks like it might be getting ready to. It might be. because now we're starting to see these. Now we're starting to see. It looks like that rotation's trying to kind of get down a little bit now to the surface. However, the thunderstorm itself, it's still somewhat there. Let's go ahead here, and I want to flip this off because this was not what I wanted. I wanted to get the good old-fashioned storm reports. Let's see here if we can't get a few little storm reports popping up here. Let's see, was there anything that was reported from that earlier storm? And the answer is we have not gotten anything quite yet. But there was certainly something that was on the ground down here earlier on. And that storm could be interesting to watch too. All right, let's go ahead here and take a look back. We got our latest radar scan yet? Nope, we're just waiting another minute or two for it. And then what we're going to go ahead and do is we're going to end this particular video, but then we're going to start with a new one. So that could be pretty fun to watch. So just waiting for the next radar scan here. Waiting to see what this good old bad boy storm here is going to try to do here. Again, we got quite a bit of wind shear. Now that inflow's starting to get filled in with rain. Let's see what it does over here, though. Still got his radar indicated, so the Weather Service hasn't spotted anything yet. Yeah, it looks like it's starting to fall apart just a little bit. Alrighty, everyone. We're going to go ahead and end this video, and we'll start up a new one. So in the meantime, make sure you look for part 2 of tonight's weather chat, I suppose, as we take a look at some good thunderstorms out across parts of the Deep South. See y'all back here in just a few moments, everyone.